Hey guys, how are you? Good evening. So we will start the session in 15 minutes at 8:30. So in the meantime, those who are already waiting for the session to start, please do introduce yourself. Do let us know about your background. Do let us know about which clouds do you work in. Do you already work with Azure DevOps or do you know what is cloud native? Any specific expectation which you have from the session? Do let us know about all that. So please introduce yourself in the chat. We'll start the session in 15 minutes at 8:30. So I just noticed that in the YouTube we have the chat window was not active, but I just have activated that. So those who are waiting for us on YouTube, if you refresh the page, you should be able to use the chat window from now onwards. Please check it out. So we will start the session at 8:30 in around 10 minutes. So please do introduce yourself. Do let us know about your background. What do you work in? Which technologies do you use? Which clouds do you work in? Is Azure, AWS, or GCP your preferred cloud? Which one is the preferred cloud? And do you already work with Azure DevOps or any other DevOps tool? Any expectation which you have from this training? And what is cloud native, right? This session is about cloud native application. So what are the characteristics of cloud native application? Is just having the application on the cloud makes it cloud native, or is it something specific which needs to be there? So any thoughts which you guys have, do let us know about that. We'll start the session in 10 minutes. Please do introduce yourself. Do let us know from where you are joining it in. And we have a lot of giveaways for the day. So there will be a quiz session which Mamta will let us know about in few minutes. And after the quiz session, there will be ebooks are available, which we have to give it to you guys. So the winners of the quiz will get the ebooks. So please use this time to introduce yourself and let us know about your expectation. I hope you have the agenda of this session with you. I'll see if I can paste that in the chat window. Okay, so there is in the chat we can see that the screen is not clear enough. Now, sometimes what happens if you are joining in the session from LinkedIn, the stream quality sometimes automatically goes down. So I'm putting the YouTube's link in the chat, and we have seen that YouTube's quality doesn't dip automatically during the session. So in the chat, I have just pasted the link. Please use that link to join on YouTube, and the quality of the session is better there. The stream quality is better there. Please use that. It's in the chat window. So we will start the session at 8:30. And in the meantime, please introduce yourself. Let us know about your expectation. And what is cloud native? Like, what's the meaning of it? So, guys, we'll start the session in next 4 minutes. Do introduce yourself. Do let us know about your background and what do you work on. Which technologies do you work with? DevOps? Do you work in which tools do you use? Do you already work with Azure DevOps or maybe DevOps on any other platform as well? Any expectation which you have from the session? So please let us know about all that. We'll start the session in next 3 minutes. So we will start the session in next 2 minutes. How to join the session? I hope the link is visible. Uh, we are starting in next 2 minutes, and those who are joining us from LinkedIn, if sometimes the stream quality dips, so I'm putting the link of YouTube stream in the chat window. You can join us on YouTube as well. The stream is having more, or the stream quality is better in YouTube. So the link is there in the chat. And that's for the LinkedIn participants as such. Right, Harsh, just check the link is there. So we are starting the session now. Vijay, what doesn't work? I hope you're able to join the session. So Mamta and Kopal are waiting. Let's get started.
Sure, Shivam. Thank you so much. Hello, everyone. Thanks for joining in. Tech Scalable is back again with another webinar that is building and deploying a cloud native application with Azure DevOps. So, who all doesn't know about Tech Scalable? Just to give you a quick brief on Tech Scalable. Tech Scalable is a training and a consulting firm. We do trainings on different multiple technologies like cloud, DevOps, machine learning, data science, and on artificial intelligence. So, speaker for today is Mamta Jha. So, just to give you a quick brief introduction on her profile, Mamta comes with a 16 plus years of experience and she has worked on different cloud platforms like AWS, Azure, Google. She has an hands on experience migrating, automating, and optimizing mission critical deployments in various cloud platforms, leveraging configuration management, CI/CD, and DevOps tools like Docker and Kubernetes. So, over to you, Mamta.
Thank you, Gopal. Hey, hi, everyone. Good evening, good morning, or good afternoon, whichever zone you guys are in. So today we are here to learn about Azure DevOps. As you know, Kubernetes is something which I'm very close to. So I've picked up AKS cluster. We would be deploying a multi-tier application in a Kubernetes environment, but that we would be doing using Azure DevOps. We would be automating the build and deployment using Azure DevOps. And once our application is deployed in AKS cluster, we will look into container insights and we will see how this new feature of Azure Monitor helps us in monitoring our application. So that would be the agenda for the day. And don't miss out, we would have a quiz at the end and we would have pretty nice books for the winners of the quiz. So we would give you all those information, the link of the quiz and whatever goodies you would be getting, the quiz winners, that information we would be giving. So here, let's start today with our session. Let me just quickly. So we would be going ahead and doing a lot of stuffs, a lot of action here. We are planning to have Azure DevOps account we have already, and the right-hand side, you can consider that as my Azure cloud. So these are the two boxes representing two different stuffs. And maybe down here, small here, I'll make my own laptop. So this is my laptop. In this, what all softwares you need to communicate, I'll just write. I have installed Azure CLI on my system. And I've also installed AKS CLI, nothing but the 𝐀𝐠𝐞𝐧𝐝𝐚 command line interface with which you can interact with your Kubernetes cluster. Yeah, these are the two softwares needed in the system. And this is my Azure DevOps account. So let me just draw, where's the cursor? Okay. So this is my DevOps account. In this, we have organization. Inside that, we would have a project. So I can have 1 to n, like multiple projects in an organization. I have, even in one account, I can have multiple organizations. I'm creating one project, and in that project, you can have various services of Azure DevOps, like I can use Azure repos to keep my code base. So this would be my remote repository, wherein my code would be kept. So my cloud native applications code is residing here. And I would have the pipelines stitched up. Pipeline created here. So this pipeline is going to be a pipeline with 2 stages. One would be the build pipeline, which is called as pipeline in Azure Pipelines, and the other one would be the release pipeline. So I saw someone was asking a question like which pipeline you would be doing. For today, we're doing a GUI-based pipeline, but yes, YAML pipeline is something which we want to keep it for the future. We would be certainly doing the YAML pipeline as well in our upcoming webinars. So build would be using an agent to build the software. This agent is nothing but a Microsoft hosted agent. I'll come to these stuffs. I'm just trying to depict what we would be doing. And after that, I'll break that further. What is a Microsoft hosted agent and all that stuff. So for release also, we would use an agent, which would be Microsoft hosted agent. This is my Azure Cloud account. In that, I create a resource group. In that resource group, I'll create my AKS cluster, multi-node cluster, like this. And we would also have Azure Container Registry wherein we will push the images. These images would be pushed to our, whatever we are building, that would be pushed to our Azure Container Registry. And we also have Azure SQL database, which would act as a backend for our. So I'll have a server in which I would run a database. Now my application got to deploy here. There are two stages in it, or two tiers rather, I would say. There are two tiers in that application. One is the front end, one is the middle, and the last one is the back end, which is sitting outside our AKS cluster. We can containerize applications like database applications as well, but here we have not done that. We are using our managed services. So front end would be connecting to the middle tier. If I'm not getting the data here, it would go ahead and fetch that from the database. So this connection has to be allowed on the server. So this we have to see. And we have to stitch up the settings between a front end and the back end. That also would be one of the tasks. Now, a user sitting outside would be able to access our application. So if I'm going to deploy my application manually, then I don't need connectivity between my DevOps and the Azure Cloud account. But if I need automated deployment, automated push of the image in my ACR would be having repo created. In that, I would keep the image. So two images are there. One is the front-end image, the back-end image. Front-end image, we are pushing. The middle tier image, we are using it from the .docker.com. Now I'll just save this picture so that we can come back to this. And let's understand a little bit more about the keywords which we are talking today. We are talking about building. We are talking about deploying. We are talking about cloud native architecture. And the last component is nothing but Azure DevOps. So here, if you look at, when we say build, because we are talking about containerized application, the building would be of two types. I would first build my app. If we have a .NET application or a Java application, in those cases, building of the app produces an executable. And in case of microservices, you have multiple executables produced. So here we are creating our app executable. Our front-end application would be built. That is a .NET Core, ASP.NET Core application. We would be producing an executable output out of that. This output we will be picking up and we would be going ahead and containerizing it. So this output would be picked up. And second, what we are building is nothing but building a Docker image. Building a Docker image. So for building Docker image, we would be using Dockerfile. And here for a change, we also use Docker Compose. We also use Docker Compose. Docker Compose is a tool which is normally used for testing and all, deploy and test a multi-container application. So we will have a separate Compose YAML file and a separate Docker file for this. Docker files can be two types. We can write good Docker file, which will help us in minimizing the footprint of our image. And that can be done in 2 stages. So you can also create multi-stage Docker file. So we will see how these files are looking like that we would discuss. So when we say building, in our case, building is 2. If it is a non-containerized application, then the build is only one type of build which we can have. But in case it is a containerized application, then it would be 2 different types of build which we can do. One would be the build of your application, and the other would be build of your container image. This image which is being produced would be pushed to our container registry. Container registries are nothing but the servers which have the ability to store images of containers, and we share that across our team to whomever you add that as a user to that container registry, to that repository, we would be able to share the image with them. Now, coming to the second point, which is nothing but deploying. Now, because we are creating containers, I can deploy that in a multiple way. I could have used Azure's web app, in which I can deploy it as a container. I could have used Azure Container Instance and deployed as a container, or we can deploy that as a container in our AKS cluster. If you have a single instance of a container which you want to run, or a single application which you want to run, I can use this. Or I have a web application which I want to containerize and run, I can choose this. We have chosen the Kubernetes. We would be deploying our application in this. So here we are actually producing 2 images, or rather I'll say we are producing one image, which is our app image, which we would keep it in the container registry. And second one is a Redis image, which would be deployed. So there would be 2 containers. This would be my backend, I can say, in one way. And I will have my frontend, which would be nothing but our actual app. This would be our frontend. Now, cloud native architecting keyword, or this word itself, says that we are developing applications to work on cloud. Monolithic applications used to have a single executable. They never used to be divided into multi-tier. They used to be a single tier application, database, the middle tier, the front end, everything used to sit together. And because of that, what used to happen, the application used to become bulky. And we used to deploy that application in virtual machines. With time, when people started to work on microservices, people started to break the application, the monolith, into multi-tier applications. And that is when we are arriving here. Like in my example, I have 3 tiers. If I keep them together, it would be called as a monolithic application, because I am separating that into 3 different pieces and I'm deploying them separately. If I want to upgrade my SQL database, voice is breaking, is it, Shiva?
Mamta, maybe if we turn off the camera, maybe it will help us out, or if we
Yeah.
go on the backup network.
Sure. Just give me 1 minute. I don't know suddenly what's the issue with the network. Just let me know if it improves.
Yeah, it is better right now. Let's continue.
Okay. Yeah, sure. So cloud native, when I was speaking about, we moved from monolithic to microservices based architecture. And in the same time, because monolithic applications were bigger in size, we used to deploy them in VMs. And now our microservices based application gets deployed in container. Cloud native does not just mean that you deploy your application in container. There are a lot of stuffs that comes with cloud native, like you need to implement circuit breakers in case you want to have a good application health. Like there are 2 microservices which communicate with each. And if this microservice is not responding, then we would not send messages to it. Rather, we would try for several times and then we will stop communicating to the second microservice and we will look for a fallback action. So a lot of stuffs has to be thought about when we are architecting a cloud native application. It's just not making the application smaller in size and deploying it and managing it does not mean cloud native. Cloud native means managing them in a better way, thinking about all failure scenarios, handling all the failure stuffs, and making sure that things are in case it's failing, then how do we handle that? So that's the reason circuit breaker means we would break the circuit if someone's not responding. Fallback means if this is not responding, what else can I do to handle that situation? So those things can be handled in a cloud native way. In cloud native, it's just not that you create containers and you deploy in Kubernetes. Your cloud native does not end here. You should have good monitoring tools. You should have better log tools, log monitoring, tracing. All those things becomes important because now we have distributed architecture. There are several microservices like this, which would be like crisscross talking to other services. And when there are a lot of communications happening across various microservices, that time it would be very difficult. In case one is failing, how do we handle that? We know in cloud, we normally have seen in virtual machines, we create multiple replicas of application, multiple copy of it. So this can have multiple copy. I can have a load balancer in front of it, and I have the instances, the containers at the back end. So now my application should not be connected directly by the neighboring microservices. They would come here and my application would communicate with something that is service responsibility of load balancing across the container instances. So cloud native is got all these like high availability, scalability, monitoring, logging, tracing, making sure that the application never goes down. And if there is something running bad, then how do we handle that scenario? That becomes a cloud native architecting. So a lot of tools are built in and around Kubernetes so that we can handle the Kubernetes-based application or deployed application in a better way. We manage them better. There are applications or tools rather developed so that we can provide persistency to our containers. Various different types of disks can be mounted. A lot of stuffs are there, which are just built for it. Okay, so this, chaos engineering, SRE, all those things comes into picture. When we are handling this chaos, which is caused in a distributed architecture, you can say that it is a chaos engineering, or a lot of people now play the role of SRE in which people handle these scenarios when things are going down. That is what it means. Now, the last keyword which we have is nothing but Azure DevOps. DevOps helps us in a lot of things, like the keyword DevOps is pretty huge, right? DevOps is a ocean. Azure DevOps provides us repos, it provides us pipelines, it provides us artifacts, it provides us test plan, it provides us boards to manage our stuff. So you can create your user stories on boards, you can keep your code in repos, you can build your pipeline to publish, build and deploy. You can save your outputs in artifact. You can save your outputs in artifact, and you can develop test plan using test plan. So these are the 5 different steps which we can do with our Azure DevOps. And Azure DevOps is just not confined to Azure. Azure DevOps has 2 different flavors. We would be using the cloud flavor of it. We would be using our Azure DevOps cloud account, but in case you want to deploy it in an on-prem and you don't want any cloud connectivity with it, you can get a server from Azure for DevOps and you can use that. This Azure DevOps doesn't confine us to Azure Cloud in another way as well, that we would not be just deploying our resources in Azure, whatever we are building, we can deploy them in on-premises, we can deploy them in other clouds as well. So that helps us in communicating or deploying. It can be taken as a separate DevOps tool. And it's a one-shop place, I'll say, because it acts like a Jira type of tool with help of boards. It acts like Git repos with Azure Repository. It acts like Jenkins and other build tools. Like in Jenkins, I to have a Maven plugin and build Maven or Gradle and all. So instead of going to Jenkins, I can do the build. I can have a build pipeline and release pipeline set up here itself. Instead of going to Jfrog Artifactory, I can deploy my artifacts in, publish my artifacts in Azure Artifacts, and I can have test plans as well developed here. It's like a one-stop shop for various DevOps stuff. So these are the things which we would be talking about. We would be building our application and we would be deploying it as container. And our application is a cloud-native application because it is divided into multiple tiers. And we would be using Azure repos and Azure pipelines today. So that's like a brief about the keywords I have explained, and let's get into action. I have already created few stuffs and kept it, but I'll go ahead and create few things so that we can start with it. I've already created a project. How can you create a project in Azure DevOps is you go to your organization, right-hand side, you have project. A project has a name, a description, and a visibility associated to it. If I create public project, anyone on the internet can view my project. If I create a private project, I would have to give access to people to be able to view my project. Or else if I have other people in my organization, I can add them as a user and I can grant them access to my Azure project. So here I've already created a project. You just got to give the name, description, and you got to create it. Because we are needing code, I have already pushed in the code here. So this is my project. You can see my repository is already populated. There are a lot of files already residing here. This is a My Health Clinic application. It's a Microsoft dummy application, you can say, which we use for a lot of demos and all that stuff. So it would get deployed and we will get a health clinic type of application. Now, there are a lot of code present over here. We are more focused on how do we build our application and deploy our application. So our repositories would be connected to Azure Pipeline. I have built and executed the pipeline already, but I'll show you how to do it and I'll rebuild it again because these steps would be taking some time and just for the test purpose as well. You can see today morning I have executed 10 hours ago and I've just tested the things are working fine. We would be also creating a release pipeline, and I'll also show you in case you want to incorporate checks in your Azure DevOps with respect to approvals, gates, and moving from one stage to another. How do we handle that? At present, I just have one stage called as dev. But if I have two clusters, dev cluster and a test cluster, and if my dev guys are approving, I can move on and deploy my application in the test, or you can say it can be a staging. That flow also we can see. So these are a few of the things. I'll just focus on Azure Pipelines a bit more. Pipelines is nothing but the build pipeline. Environment is something which you can create when you have various stages, the dev stage, the prod stage or the staging stage. That time you can create a corresponding dev environment, a stage environment, and a prod environment. Now, releases is the release pipeline. You have library section here, wherein you can create variable groups. This can be a set of variables which I can add, which can be used across different pipelines in this project. So Variables can be created in multiple places. I can create them as variable group here. If I go back to the library section, you can see there is an option to create secure files. Secure files in Azure help us in uploading files which would be encrypted. They would have encryption associated to it. So if any sensitive files like certificate, keys, password, or any account related information like my tenant ID and all is there, which I don't want to check in as a file in my Azure repos, then I can upload that in a secure file section. You have to do nothing. You just click on secure file, browse, and place that here. You would be able to provide access as well to users with help of your options over here. Now, there are something called as task groups as well. When we are building up a pipeline, we would be doing a lot of tasks inside it. Let me go back to this, clean up this page, and let's understand a few things about the pipeline. So I said that my pipeline can be of two types: a build pipeline and a release pipeline. These are two stages, a build stage and a release stage, you can say like. So I can create my pipeline in two different ways. I can create my pipeline in YAML coding. I can create my pipeline with the graphical editor. It is called as graphical editor. So if we are new to it, we use graphical editor. If we know YAML coding, we can go ahead and create a YAML-based pipeline as well. So in the build pipeline section, we will be having our pipeline will have few important keywords. Every pipeline would need a trigger. It would have an input associated to it. It would have an output. And this can be of two types. It can be, let me just draw it down like a tree. That would make more sense. So the trigger can be a scheduled trigger, or a trigger can be a continuous integration trigger. We see CI/CD pipeline. This is the CI, the continuous integration trigger. Schedule trigger is like every Tuesday building at 10:30 p.m. and building it on every second day, Tuesday, Thursday, Saturday, I'm building up like that. And continuous integration, which is there, that is every commit or every push to the repository will trigger a pipeline. Graphical editor and the YAML editor, there are two different types of YAML editor. Here you would be coding your pipeline. So you can save this as a code in your repository. In this, you would have graphical way of pick and choose your tasks which you want to do inside a pipeline. This is a little bit more user-friendly, and you can have this. Classical editor is the graphical way of doing it. It's called the classical editor as well. In the GUI base we do. That's the reason I've named it as a graphical editor. Now, with this build, we would be building. So this pipeline would have jobs. It can have multiple jobs. Any job execution would need a server to execute that. That is called as agent. I can get this agent from two different places. Like I can have my own self-hosted agent, or I can have my Microsoft hosted agent. And this agent which is there, that would be our task execution. So jobs will have the tasks in it, which is called as steps, and the step scripts to be executed or tasks to be executed. So there would be multiple tasks like this, and I can have more jobs as well. Like I can say job 1 in my pipeline and job 2 in my pipeline. This is having more tasks inside it. I can have multiple of them. And for every job, I can pick up an agent. I can have different configuration. So what is a Microsoft hosted agent and a self-hosted agent? Suppose I'm doing a Docker image creation, say Docker build, or I'm building my .NET application. I would need Visual Studio 2017. I would need packages with I can build my .NET application. I would need Docker in that system if I want to do a Docker build and produce an image out of it. So agent would be the one in which we would be executing these tasks. So the packages would be actually installed on the agents. If on demand, I pick it up from Microsoft, they are called as Microsoft hosted agent. You specify your requirement, what packages would be needed for it, and it would make your application server ready like that, or the build server, sorry, not application server. It would configure the build server as per the need, and it would go ahead and build. In case you don't want to take on-demand Microsoft hosted agent, because this would be not under our control, we can go for self-hosted agents. Self-hosted agents are our servers. We can configure our on-premises server, or we have servers running in cloud that also can be configured so that we can execute the build. But responsibility here is to manage them, maintain them. There would be an agent running so that it can communicate with our Azure DevOps account and listen to any of the jobs which are being allocated to it for building and for deploying. So whether it is a build pipeline or is a release pipeline, I need a trigger to it. I would need an input. In case of build pipeline, the input would be my code, nothing but the repositories. But in case of the release pipeline, my input would be the build output. The input would be the build output, which I would be taking up and I would be building. And here, output is nothing but deploying the application. Here, the output is nothing but we would be going ahead and producing the executables or the image. That would be the output for this particular stage. So these are a few of the basic building blocks which are there. We would be having build pipeline set up to build our application. Let's see how do we build our application. Now, moving on to the next stage, we have understood any questions. If there are questions, I'll pick up. What is a release pipeline? Release pipeline is nothing but a deployment pipeline in which you go ahead and release your software in a particular environment. You go ahead and deploy your application in a particular environment. Harsh, that would be called as a release pipeline. I would be deploying my application, in our case, in AKS cluster. That would be the releasing of the application in that stage. And that's the reason that pipeline is called as a release pipeline. So DevOps has two important phases, CI and CD. That CD is nothing but the release and CI is nothing but the build. So you can say this part is the CI part. This part is the CI part. And this part is the CD part of it. So jar files, var files would be produced as an output here. And that would be taken up by the release pipeline and deployed in the end servers in the deployment stage, the CD stage. So output would be jar and var, or whichever language you're working on, dependent on that. And that would be picked up. And here, when you deploy them into servers, that is the CI/CD. So it entirely depends on our application, what type of artifacts would be produced. Like in our case, because we have taken containers, then we are building up our container images out of it and then pushing that to the Azure Container Registry. Arshia has asked very good question. This question, a lot of people ask each other. CD means continuous deployment. CD means continuous delivery sometimes. What exactly is the difference between them? When you're deploying in two stages, that time you call as dev stage, QA stage, when we are doing it within our setup, that's called as normally continuous deployment. When we go and deliver that software version to the customer, that becomes a continuous delivery. So as per my definition, I would say it's nowhere it is, if you go and look, you would not find anywhere it is documented it that well. But continuous delivery means releasing the version to the customer when we do in a continuous fashion. That is called as continuous delivery. ACR is part of both the cases, Gyan. It's just not part of the build and the release, because we would be building our images, we would be pushing the image in ACR. And when we are deploying, our image has to be pulled from ACR and deployed. And that's the reason we would be saying that Azure Container Registry comes in both the phases. So I'll just save this in case we need it for the future. Referencing something, let me quickly just name it different. So let's look into some tasks which we would be creating. We have understood about the basic blocks. Our code is here. I'll first get into the code and then get into the tasks. So I have multiple compose related files here. Compose CI build is one, and then the compose is one. There are two different stages, stuff's being given over here. So let me go back there, and rather let me open a new tab. So I am building two different stuffs here. You can see here there are two different Docker files. One is called as Docker Compose and one is Docker Compose CI build. And here you can see that image name is being given. We are picking up a basic image and then we are picking up the entire code from the source directory. And we are going ahead and executing some commands so that we can do a .NET build and a .NET publishing of the output file. So this would be produced as an output and we would be publishing that output of the .NET application build. So this is going to do a application build. I'm not getting into Docker basics and all because we are not into a Docker session. So I'm just skipping that. We would be focusing more on adding tasks to our pipeline rather than spending time on the Docker Compose and the Kubernetes files. So just to give a brief, we are having one service. We are building the code here. We are picking up a basic image and we are building up the code. The .NET build happens with this. The other one is using a Docker file and producing a Docker image. So two different things we are doing here. In the second one, the output is nothing but the Docker image, which we would be using. So let me show you this Docker file as well. Docker file is present in SRC folder inside My Health Web. This is the Docker file. So I'm starting with a base image. I have an arg, which is nothing but an argument. And I'm setting my work directory as /app. This application needs to listen on port number 80 when we are building it. Whatever we have published as part of the previous build, which has happened as part of the CI build, that we are picking up here and copying that with a dot. That means I would be copying that into that temporary container, which would be building up the stuffs. So, and when the application starts, we would be starting our DLL, which is actually going to run our application. Now, the context which we are setting here is having this ./src my health web. We are picking up the source from here, and then we are using this Docker file and we are doing this. Remember that this is a compose file. This is just not a Docker file. I am saying that to build My Health Web container, you will have to use a Docker file, build an image, and call that image as my health web. That would be the output of the image that I would be producing. So I'm giving the context because my Docker file is present over here. So here dot slash means in the present directory. From there, I'm going to SRC. It's a relative path being mentioned over here for it to identify where it needs to go. And here you are seeing there is another volume set. I can have my persistent volumes created with the help of host path mounting. So whatever is in the present directory, wherever this file is present, I'm copying everything inside /src so that I can build inside this container. So here, this is one service. This will build up a container. It comes up with this. It copies the code, and then it goes ahead and builds the code. This command would need the entire SRC folder. If I don't have that SRC folder, I would not be able to build my application. So container is created in which we would be doing a .NET build. .NET build is not done on a virtual machine. It is done inside a container. And this step means that you're copying the entire dot directory. That means whatever is present in this present working directory, that would be copied inside /src in the container. And I'm setting whoever gets inside this container by default will move on to /src. And then I'm going and executing this, wherein in the bash prompt, I'm building my .NET application and I'm producing the output. So this is the image which would get produced here. We are building the Docker image and we would be using this Docker file during our task. So these are the three basic things which we are doing from the containers perspective and building up our application in a containerized manner. There is one more file which I want to show is the Kubernetes YAML file that would be used in the deployment phase. Let me hold on this. Let's go to the build pipeline and then execute it and see how does that work. So here I went to pipeline. If I want to create a new pipeline, I can create a new pipeline. I can go with a classical editor. I can go with a graphical editor option or YAML editor option. Here it is asking me for a source. Where is your source code present? It is present in this project. This is the name of the repository, and this is the branch I would like to build. I say continue. It is asking me, do you want to take a skeleton of any of the templates so that you can go ahead and build a good pipeline, so that you can build a good pipeline. So if I'm going ahead and picking up any skeleton, like I wanted Docker build image to happen, Docker push to happen, most of my tasks are related to Docker. So I can choose this and I can say apply. You can see here automatically tasks have come in. This is because I've chosen a template. You can choose not to have a template, and you can even go with an empty job and add your tasks as well. Because I know I'm building up Docker, I can go and choose this. So these are nothing but templates which helps us in building our pipeline. You can pick up a template according to your choice. If I would have been building ASP.NET in my, like a task would have been there to build the .NET application, I would have had a task corresponding to it. Here we are not doing that. We are building a Docker container image, and that's the reason I'm choosing up this particular task as my skeleton. I'll say apply. Let's see. I'll try and add few tasks for you and show you how would that work. So here in the pipeline section, there are various stuffs on the top tab. You can see here that there is a task section, which is nothing but having all the tasks. So this is the head of the pipeline. This is the name of the job. You can call it as job 1. This is the name of the job. in first job, what type of agent you would be expecting to use. I can say inherit from the pipeline. I can define the agent on the pipeline level itself. I am saying for the entire pipeline, I may use an agent, which is nothing but Ubuntu 16.04. And you can see your agent pool. When I say Azure Pipelines, it picks up agent on demand and it grabs a server to do the build process. Source code is given here, where the source is there. We had just selected this. That is that source which we are talking about. Now, if I have a job, my job can inherit from the pipeline, or I want to choose anything else, I can choose other agent as well. From the pool, I can choose a specific, say, another agent I want to use for this particular task alone. I can go ahead and do that. If I need very specific requirements for my application level for an agent to be configured, something very specific, then in that case, you can add capabilities over here and you can say that this needs to exist in the system so that I can pick that for build. Parallelism is there, which is none. I can run this in multiple configurations parallelly. I can run them in multi-agents parallelly to reduce the time. If I want to do the tasks which are not dependent on each other, I would be able to do that. Here, our tasks are dependent. Unless and until I build, I can't push my image. Unless and until I push my image, I can't go and publish it. So our tasks are dependent. So I'm just saying no parallelism. We will go that in a sequential manner. Now, these are the tasks. One task is to build an image. So when you are coming to this task, you can give a name for it. You can say building of your application. Here you can say that you are providing your Azure Container Registry. If you have already created an Azure Container Registry, there is an option of a container registry. If you have a different registry, you can even go ahead and choose that registry. At present, my Azure Container Registry is created, so I'm just choosing that. Just checking if the voice and all is clear. Yep. Now, here you can go ahead and select your subscription in which you want to deploy. If you're choosing a subscription newly, like if any subscription you want to choose newly, you will have to click on authorize. What happens in case of a subscription drop-down selected over there? Now, let's try and understand this. Azure DevOps is a different service. Azure Cloud is a different service. They both need to talk to each other. They both need to talk to each other. For them to talk to each other, they will have to authenticate. So if I take my subscription, whatever subscription I'm planning to use here, that subscription I need to add in here, and I would say that this is the subscription. With this authentication, I would be getting in. So we need to create something called a service connection. Service connection. We can create service connection on a subscription using subscription details. Or if you have a service principal in Azure for role-based access control, we create service principal and we grant access to users. So for corresponding to this service principal, if I want to create a service connection, I can even do that. When I create the service connection in any task, if I use my service connection too, it will get any access which would be actually granted for this. Whatever is being given, permissions are given for this, that access would be granted to this. If I'm creating a subscription level access, it will get the access of the entire subscription. So how do we create a service connection? I'll come back to this. Let me go ahead and show you. In the project settings, inside pipeline, there is an option to create a service connection. you could create a new service connection. There are different types of service connections which are getting listed here. Service connection comes into picture when you want to communicate to a server which is outside. Any third-party tool or anything which is not within Azure DevOps. Like I want to communicate with my Azure cloud account. It is outside my Azure, say Azure DevOps. I want to communicate with Git, Bitbucket Cloud. I want to communicate with Docker Hub. Those needs an authentication. If I'm saying connect to my hub.docker.com, don't you guys think it will ask me, hey, Mamta, what's your username and password to connect to your hub.docker.com? Correct? So any third-party service, when we want to send a notification to do an action over there, I want to communicate with it, I would need authenticity for that. And that is when we create a service connection. Because we are going and picking up the subscription level, it normally comes here. You can go and create it in an automatic way. You will see here, it automatically populates my subscription and I can give a name for it and I can save it. You can see here, I've created a lot of them present over here. The connections which I have created it, they are there. So if I want to create one, I can go ahead and create one by just giving this. I can say this is the resource group, like one resource group in which I want to deploy something. So in this subscription, in this resource group, it will allow me to do the things. We can scan the image before deploying. That feature is there in ACR. If you enable that, it would certainly scan your image. Otherwise, if I want to use tools which are open source tools and scan it, I can install that software in my Microsoft hosted agent and I can execute corresponding commands to do that. Because ACR supports that, I will not take that much of effort of including such tasks in my pipeline. Now, this is how you create a service connection. I have chosen the manual option. I'll just show you another subscription. Like you want to communicate to your Jenkins. Then you can give your Jenkins server's URL, your username and password. Click on verify. It should be able to authenticate. Then you give a name for it and you can have it. So now you might be thinking, Mamta is saying we can do a build and deploy in Jenkins, then why build and deploy in Azure Pipeline, then why we are talking about Jenkins? Many times when customers migrate, they don't migrate everything immediately to Azure DevOps, right? My build might be running in Jenkins, my deployment might be running from Azure DevOps, or it would be the other way around. I'm doing a deployment using Jenkins, I'm doing a build using Azure Pipeline, and to deploy, I want to trigger Jenkins deployment. Never know. We can use that. I want to authenticate with my GitHub account. I want to interact with Jira. I want to deploy a Kubernetes cluster. With that, I want to authenticate. So in those cases, we need these. So here you can see I have created an Azure connection, AKS connection, in which it actually verifies my connectivity for my AKS cluster. I have created that sometime before for this. So this was for the service connection. Now going back to this. So if it is already created once, you can see here it says you already have this authenticated. You don't have to do that. Once it is authenticated, it would be visible as Azure Service Connection. Till the time it is not authenticated, it would be in the second dropdown. So I'm picking up my application subscription in which I would want to deploy my application. Container registry name should automatically pop up in case ACR is present. So here, ACR came in the dropdown because Mamta has already created an ACR. If I take you to my resource group, I have a Kubernetes cluster, I have a container registry, I have a SQL server and a SQL DB. You don't have to do too much of effort in creating a container registry and all. You can do it from here, or you can create that from the command line as well. There is a little bit of twist when your AKS and ACR interact. You have to keep something in mind that I'll emphasize on when we are reaching this stage. At present, my container registry name is this. In case the video is buffering, you people can move on to YouTube. In case you're looking into LinkedIn, Hari Bunch, sorry, YouTube has a better rendering capability. So you can go ahead and listen to our video on YouTube. Testing of the images can be done here itself. You can add tasks in this pipeline itself, Tarun. You don't have to do anything extra. We can test the container images and then go ahead and push that to the container registry. We can do that. Now, coming to this location, my Azure Container Registry entire name is this. I'm emphasizing on this because we would be using this name for our variable section. So we would be creating some variables in which we would be saying what is the complete name of my Azure Container Registry, what is the name of my database, what is the username, what is the password. We would not be hard coding those stuffs. Few things are sensitive. A DB password is sensitive, right? We can save that in a variable and then encrypt it as well. So we will see those things. This is my Azure Container Registry, which we had chosen them in the drop-down. So you can write multiple tasks here. You can say what you want to build and how do you want to build, right? What action would you like to do? You can pick and choose over here. So here, I would go back to my pre-created pipeline and I'll try and explain that rather than building it from scratch. Let me quickly go and do that because it would take a lot of time otherwise. So here, pipeline. This is the input, the source. I have two more tasks. If there are variables which are present in our JSON files or any variable which is present in our YAML files and we want to replace that during the runtime, you can go ahead and use this replace token. Replace tokens. These are normally used for it. JSON file is there. In that, you want to change a few things that would be replaced, or in your MSC AKS file. Actually, I don't have a variable here. Just to showcase, I have added this. Now coming to the run service, here I have chosen my subscription. I have chosen my container registry. Here I'm giving which Docker Compose file it should execute. So in this stage, we would be actually building image. You can see here, we would be building an image, run service images. We would build an image and we would abort the container on exit. Because we are using a Docker Compose tool, it will just not build it, but it will create containers as well. And we would have an image created. So there were two stages. One was the building of our application in which the CI build Docker Compose YAML was used. The second one, all these four tasks are similar. It's just that the action which we are doing, that we are changing here. In the first two tasks, both are exactly similar. Here I'm choosing my CI build.yaml, and here I'm choosing my Docker Compose.yaml. This stage, I would say build .NET application, and this stage is building Docker image. This is the difference. I'm executing two different YAML files in these cases. Now coming to the push. Once you have produced an image, you have to push that to the container registry. And that is where you use this. You are building up the image, and here you can see push service images. Build, push, run a specific service image, lock an image. These are few actions we can perform in this particular task, we are picking up push image. This is the way we would be tagging. We also would be tagging our image with :latest. That means if I execute this pipeline, it should push an image in our container registry. Container registry details are also specified over here. Because I have executed this pipeline before, you can find here that in this container registry, I have repositories. And in this repo, I have my health repo. I have other applications which I have pushed in the past. And this is the application which we are talking about. So a server will have repos. Repos will have various versions of it. So I've pushed images several times. That's the reason it is having these many of it. If I click on latest, it will give me the entire details. It also says how can I pull and use this image. You can see here there is a manifest file giving us the details about it. So this is my repo. So how is it? Container registry is a server. In that you can have several repositories like my WordPress application if I'm pushing, or another application I'm pushing. They are kept in a different repository. This is for just my health clinic app. And in that, as many times I build, I would have newer versions of the image. According to the build number, it is getting tagged. So I have built these projects in last 4 or 5 years from the time I'm giving training of Azure DevOps. I've built them 700 times. So you can just imagine how many times we have delivered the session. Yeah, just coming back to this. This is pushing the image. And we are tagging here. Obviously, tag option is there. You want to have any source tag, you can here do the source tag. You have option, include latest tag, source tag, or the build number gets introduced here. So Vishwanath, just to answer your question, you have that option. With the commit IDs, you can also do that. Now coming to the next task, which is lock task. Whenever you push an image, you want that image to be locked so that it is safe. No one else is able to overwrite the image. So locking can be done on 2 levels. If you do it on the repository level, no one would be able to push newer versions of it. Like in a repository, I have this as a server. Sorry, so bad in drawing a straight line with this drawing board. That is only because this tool draws is better and we are so habituated with that. So getting back to the non-scalar mode. Yeah, this is my Azure Container Registry. In this, I have repository. In this, I can put a lock. Then no one will be able to push various versions of the image. I have version 1, version 2, version 3. You will not be able to push newer version of the image. But if I don't introduce a lock here, rather, I introduce a lock on this level, then I would be having, no one would be allowed to edit this image, delete this image. People would be able to pull it, but people will not be able to play with that image and edit that image. Nothing can be done. Deletion, rather, I will not say editing image. Image editing is a wrong word which I've used. I'm sorry for it. You won't be able to do a delete action on that. So you can see here, we are just picking up and saying lock service images. This is the action we would be performing. Now, these images are produced and image is pushed to the container registry. Now I'll bring back my first picture, which we had discussed. It's time to see that. Sorry, open recent. So here we have basic things. I had mentioned the image of this one would be picked from hub.docker.com. image of this is picked from ACR. What about the database? You need to publish the database as well. That also we need to do. So we would look into the next task. So one image is picked from the Azure Container Registry. Another image is picked from the hub.docker.com. Now let's see the copy files. There are two files which we need to copy. Can you see this? The contents. You mentioned the path over here and the name of the file. The database DATPack file is here, plus your Kubernetes YAML file is here. Kubernetes YAML file would be used during the deployment phase in the release pipeline. I need to publish this to the release pipeline so that release pipeline can pick up that file and can go ahead and use it during the deployment phase. If I don't publish it, it will not be able to pick up, because what did we mention? That release pipeline takes input from the build pipeline. Release pipeline takes input from the build pipeline, and build pipeline is taking input from the repository. So I'm just copying few files. They don't need a build. They don't need anything. I'm just copying the file. And you can see here, target folder is this. This is a keyword, a predefined variable in Azure DevOps. I have artifacts produced on the pipeline level itself so that from this pipeline itself, my release pipeline can pick up. I'm not saving it in a different place. So this is the only piece which we have to do here. I have copied it to this place. Now I will publish it so that my pipeline can pick up. So you are saying that path to publish is this, and inside this folder, whatever will be the value of it with respect to it's a variable type of thing, right? So whatever would be the value for it, I would be going ahead and creating a small folder called as deploy, and in that I'll put both the files. My, say, your DATPack file and your AKS file, or I will say Kubernetes YAML file. Now, this would be published in Azure Pipeline. You have option of file share as well. I'm using Azure Pipeline. That means in this pipeline itself, it would be used. Now, this was the task section. There is a question here. I would like to pick that up. Tarun is asking, why are we not using, or Gyan rather has asked, why are we using hub.docker.com? So there is a proprietary image of my application that is being deployed here. For that, I can't go to hub.docker.com. But the Redis application which is there, that is not a customized Redis. I can pick that from anywhere else. So we are picking up that from the hub.docker.com. If you want to build this image and push this repo as well, then you will have two repo, one My Health repo and one Redis repo. You can certainly do that as well. We are picking one from hub.docker.com and one we are picking up from the ACR. ACR has our proprietary application and hub.docker.com has our application, which is standard image of Redis. So we have tagged our image with the build ID and with tag latest, both, Tarun. It would be tagging two things. It would tag every build image with latest, and every time that latest image would be overwritten. If you go to your Azure Container Registry, if I pick up the latest image this time, actually I'll be getting 786 tagged image. If I would have taken it before, I would have got 785 tagged image. Hope that makes sense. Coming back to this. So this pipeline tasks are explained. Now there are variable section. You can write the variable values here. You can just say add, give the key and the value for it. And if like this is a SQL password, you can go ahead and encrypt it. You can encrypt it as well with a lock. So I have my Azure Container Registry name, the entire DNS name I'm picking up. This is my SQL password. This is my SQL server. The SQL server's DNS name I've picked up. So this is my SQL server. You can go and find the DNS name over here, the server name that is being picked up. The complete name is needed. The SQL user, which is there. And there are few standard system stuffs. If you want to give, you can give there, like anywhere the variable like system team project is used, then I've given the name of the project. We can also certainly pass our applications SQL passwords using Azure Key Vault. Yes, that is the best way of doing it. If we are actually implementing that in a real time, then SQL password would be fetched from Azure Key Vault from the pipeline itself, and it would be used. Very correct. Now coming to the trigger section, if you enable this, continuous integration gets enabled. If you select this, you can define a schedule when you want to actually go ahead and do the build. On build completion, if you want to do something, that also can be provided over here. I want to go ahead and do another build pipeline execution, then I can go ahead and do that. Now coming to this, there are two options over here. Enable continuous integration and batch changes while a build is in progress. Let's try and understand this. So let's take an example that Mamta checked in the code and build pipeline got executed. Build pipeline got executed and it is running. It takes around 5 minutes for the build to happen. It started at 8:30 p.m. Within this 5 minutes till 8:35 p.m., till the time this build gets completed, my few other team members, like take example like Gyan and Tarun, have pushed in their code. Gyan has pushed in at say 8:33 and Tarun has pushed in at 8:34. So what would happen in that case? In between 8:30 and 8:35, I have several build requests. Now, this build is going to take 5 minutes. Once this finishes, it will come and picks Gyan's build. It will again go and spend 5 minutes on that. That means 8:30 to 8:35, Mamta's build is going to run. Gyan's build is going to run from 8:35 to 8:40. Then Tarun's build is going to run from 8:40 to 8:45. Little bit looking foolish. So if you say batch, if you enable that second checkbox, it can be batched. That means if one build execution is going on and I have multiple push, I can batch them together and there would be a single build happening. At 8:35, both Gyan and Tarun's changes would be picked up and 8:40, both of their builds would be finished. Instead of doing 2 more runs, we would do that. You can do that in parallel. Yes, it entirely depends. You can pick up various different agents and you can do that. At present, we are asking for one Microsoft hosted agent. That's the reason only one is there. If you have multiple agents, then self-hosted agents are there. My agents are free, then yes, we can do a parallel execution on them. Now coming back to this pipeline section, trigger we have understood. If I do this, we understand what the difference it would cause. Here, if I want to include, exclude any path file, any folder which I don't want to consider from the repository, that can be mentioned over here. Options are here. Build number format, which we have, that comes from here. If you want to change that, you can change that over here. Build job timeout is in minutes is given in 60 minutes. If the task is running for 60 minutes and it is not ending, it would time out that. It may think that it is stuck for some reason. If I have triggered a build job, I can cancel that within 5 minutes. Cancel timeout is 5 minutes. Now, history gives who has updated, what is updated, when it was updated. That comes up over here. Save and queue option lets us save and queue the pipeline. For now, I'll just say save and save the changes. At present, I've not made any changes, then I don't need to save it. And summary section gives you the entire summary of previous runs, when it failed, when it passed, what happened, a lot of stuffs. Why I was trying out this pipeline, because the standard .NET image, which is being used in these files, were moved from the standard Microsoft Docker Hub repositories to a different location altogether. And these projects were not building good. You can see here, it was failing before. And that's the reason I just updated those images and tried out whether it is building fine or not. So this is the build pipeline. I'll execute it. If I execute it, it will go to the deployment as well. That's the reason I'll execute them together. Not now. I'll execute that after a while. Now let's move on to the release phase. Release pipeline is shown over here. You can go ahead and edit a pipeline, or you can create a new pipeline from here. You can do both the things. If you are creating a new pipeline, you need to know what sort of tasks you would be having. So I would just go ahead and create a new release pipeline. You can see here, it is asking what type of template would you like to have over here? What sort of template would you like to pick up? Because I'm deploying it to a Kubernetes cluster, I would go ahead and pick this template so that my life is a bit simplified picking up those tasks. It is asking me about stage. I had mentioned that your pipeline can move from one stage to another. I can say this is a dev stage and just close this. I can add multiple tasks inside this. Release pipeline is asking for artifacts location. I'm saying that in this project, there is a build pipeline, and that build pipeline is building, and whatever is the latest build, just a second, this pop-up is blocking, you can go ahead and add it. This would be the source for it. My release pipeline is picking up the source from it. It's picking up the source from it. Now, you can also schedule from here. If you don't want to do a continuous deployment, you can schedule the deployment. You can enable this and you can schedule it. You can have multiple scheduling, multiple schedule for scheduling, rather, I would say. In case I don't want to go with the scheduled one, I can enable continuous deployment. If I enable this, I would have a continuous deployment. This is one flag which we can set up. Every time there is a successful build, I would have the deployment also getting triggered. Now, there was a question some time back in the chat I saw, what would happen if the build fails? Nothing would happen. The build would fail and it will mark it as red. You will get an email saying that your build has failed. Whoever have subscribed for that build pipeline, everyone will get a notification that the build has failed and you need to take corrective measures to make that build pass. That's what you can do. Now, you can see another one over here. Pull request trigger. Just going back to my drawing board, I'm too much addicted to this. Okay. So build can happen with every push. This is the final push of the code. This is the final push of the code because I have well tested and validated everything. But imagine that I'm a coder in my team and I have committed the code in my local. This is my local laptop. I have done a git commit here. I would first create a pull request, which will go through the code review cycle. Everyone is satisfied when the code review closes. Then this code would be taken by the main branch or whatever branch I am checking in. Arrow mark looks really weird. Okay. It would be picking up this. So this master branch, which is there, that would pick up only when, this is the commit ID, it would pick up only when the code review is there. So this would be a merge from a pull request branch to the main branch. Merge type, you can select. There are various types of merge, squash merge, say linear merge and all that. I'm not getting into that. You just that whatever code changes you have done, that would be actually taken up into the main branch. And because I have got a code change, I would be doing a build. This is this build. Because I have a code change, I'm doing a build. But what happens if people are sitting and doing a code review? If I can give them a better perspective to review the code by doing some tests, seeing whether the build is passing with Mamta's code or not, running a sonar analysis, for example, sonar cube analysis. Whenever we want to submit the code, it actually creates a pull request. You can't go ahead and commit in any of the branches directly in the actual workspace. So you create a request to submit. That is called as a pull request. You can say this is like a submission request. When this is done, you can have set of reviewers for your code, and those reviewers would be reviewing our code. And when the pull request gets closed, that time the actual code is pushed here. So Mamta would have raised a pull request. Coders have given comment 1, for example. Mamta addresses that, commits again, and updates that to the pull request. Then again, I got second comment. There is a code change needed. Mamta will make the code change again, and she will again put that to the code review. So this is having multiple commits. I'm just updating my code with all the bug fixes, whatever flaws I have in my code. Everything is here. There can be multiple commits if I'm not coded it well, right? And this pull request would be reviewed, and when it closes, that time it goes ahead and merges to my branch. There is a difference between a git pull and a pull request. Pull request is created during code review phase. Git pull you do, like for example, Gyan, you are the person who is sitting and working on the other laptop, and you are my team member. Now, Mamta has already checked in this code. You are also building on the code. If you try to push the changes, it would say that your changes are stale. You first need to pull Mamta's changes, and then only you would be able to push your changes to the central server. So this is called as git pull. Git pull takes delta code changes from remote to local. From remote to local. That is called as git pull. This is different pull. Now, this option, which was there on the screen, if I do this, this pipeline will start to trigger for every pull request which comes. Like I can have multiple branches in my repository, right? I can select a branch, like in master branch, whenever there is a build, whenever there is a pull request created, execute this pipeline. Pipeline is going to remain the same. It would trigger in both the scenarios. It would trigger here as well, and it would trigger here as well. That's the difference. Because it would have executed once, the output is visible to the code reviewers. They will have a better perspective towards the code. They will understand the flaws. They can predict what can go wrong and all that stuff. So that helps us in attaining a cleaner code or a good stat for the code, and just having a quicker resolution in case things go wrong. Now coming to this section. So I was in the pipeline. The next tab is task. Either you can go from here or you can go from here. In this task, you can see I can edit and update a lot of stuffs. Like I'm saying a name for it. I can have a name for my task. I can say my deployment task. I can have that name for it. And I can also go ahead and provide my connection name. So connection name would come into picture when we are actually using our Azure Kubernetes service. And I want to create a connection with AKS. That time you would be selecting the service connection. I'll come to that in a while. In which Kubernetes cluster, in which namespace I want to deploy my application, those things have to be specified. Now, taking you to the already built pipeline so that it has all the data populated, I'll go ahead and edit this. You can see I've taken the input. The input is same. I have two jobs here. A job for doing a DB deployment, a job for doing an AKS deployment. Two different jobs. They are two different stuffs, right? DB deployment will go and deploy your DACPAC file. Your AKS deployment is going to create your Kubernetes application, deploy your Kubernetes application to it. So it is not going to create a Kubernetes cluster. We can create a Kubernetes cluster if we club that with a, say, Terraform script I'm running or an Ansible playbook I'm running as part of this task, then I can even automate the AKS cluster creation. That I'm not covering today. We can go ahead and deploy that in an existing cluster. You can see here, I've picked up my subscription name, the resource group, and the Kubernetes cluster. So this cluster is already existing in my resource group, which I have created. It's pretty simple to create an ACR and AKS. It's not that difficult. You can create it from here. You can say Kubernetes, and you can create it from here. You can go ahead and create it, or there are simple commands with which you can go ahead and create it. I'll just give you the commands. There is a link wherein you can find the commands. I'll share the link in a while. So here you are saying in which subscription, in which resource group, what is the cluster name, in which region, what version of cluster you would be deploying, and what type of nodes you would be having in them. You can go ahead and do that. Now, this cluster creation can be done and container registry. Container registry is here. It's pretty simple. You can go ahead and specify just the registry name and what would be the SKU, the basic, the standard, the premium. Depending on that, you would have the replication factor where you are going to save your container images that you're specifying over here. I don't think we would edit any more stuff. So I'm using my pre-built Kubernetes cluster, which I already have here. I have just one node pool with one node here. I can go ahead and scale my node as well. I can scale from one node to two node cluster like this. I can even execute the scale command to scale it. It can be done from the command line interface as well. So it is scaling my clusters from one node to two node cluster now. Going back to the pipelines once again. So here you are saying in which subscription, under which resource group, where is your cluster, in that and which namespace you would deploy. Namespace helps us in segregating the resources and having a role-based access control implemented on it, plus limiting the amount of resources which can be used in a namespace. You can see here we are using apply command. So you can create your application with kubectl create, or you can create your application with kubectl apply. If I say create, it would be creating the application for the first time. If I say apply, if it has not created the application or deployed the application in the past, it will go ahead and deploy it. If it has already deployed, it will look for the delta changes and it will go ahead and deploy that Delta version of it. So you can say like upgrading your application. Here, one important thing is the second half of the section. You can see here what is a secret. I am saying that Docker registry is the type of this container registry. Every registry backend is nothing but a Docker registry. Docker as a company, like how Nginx company releases Nginx image or Redis company releases Redis image, Docker as a company releases Docker repository servers or Docker servers image, which has the capability of keeping images in layered format and all that stuff. So this container registry type would be Docker registry. I am picking up my container registry. I'm giving the subscription and I'm giving which container registry. And you can see here my secret key. This my secret key is the key with which your AKS will authenticate to your ACR. Now going back to the first picture which we had drawn. When you are building, you have pushed the image from here to here. It is being pushed. In the release pipeline, you're executing a Kubernetes YAML file. And we can go ahead and pull the image from here. We would be pulling the image and deploying it. When AKS goes and talks to your Azure Container Registry to pull the image, it will have to authenticate. ACR will just not give away the image to anyone else, right? So we will have to authenticate. For that, we normally execute a attach ACR command, which helps us in attaching our AKS to a Azure Container Registry. A service principal gets created, and we say that AKS would be using that service principal. And we are giving access capabilities for pulling images from ACR. Pull is the capability we would be giving. So our AKS cluster can go ahead and pull the image and deploy it. When you are executing the Kubernetes YAML file here, it is actually interacting with your AKS cluster and the application gets deployed here. To deploy this application, it will go pull the image from ACR and deploy it. We can certainly use your, say, Helm charts. I need to have a readily available chart for it. If I have Helm charts, I can deploy Helm charts as well. Instead of picking up this task, I will pick up the Helm task and I can use Helm charts for the deployment. This is a basic one. I'm not using Helm charts here. I have added one more task over here called as update image, in which if I want to set a specific version of image, I can go ahead and do that. So kubectl set is a command with which we can update the image version. So if I was running with version 1 and kubectl set image runs with version 2, it would deploy newer versions of the container. You can see here what argument it takes. With respect to the build ID, it would be picking up the image from ACR and it would be deploying the front-end application. The name of the deployment is MHC front, and the container's name is also MHC front. That would be updated with the newer version of the image. Here also, you will have the secret section. Wherever AKS is going and interacting with your Azure Container Registry, we would need those secrets over there. Before proceeding ahead, let me show you the file of our AKS deployment. This is what will get executed in those tasks. kubectl apply -f mhc aks.yaml, kubectl apply -f your kubectl set, that command would also go with this. So in both the cases, we are using this, and that's the reason we need to understand it. This file has two deployments and two services defined. One deployment is for the backend. You can see here the My Health Clinic backend. I'm deploying one replica of it, and I have a selector for the controller so that it can work with the container. It can identify the pod. This is the pod's label. So I'm identifying the deployments. I'm setting the deployment to the pod, you can see. Container specification, you can see the backend. I had mentioned we have just specified Redis. When you just specify Redis, it understands that it has to go to hub.docker.com and pick up Redis, because the default repository which gets configured is nothing but the Docker hub. My container is listening on port number 6379. Redis listens on this port, that is the one. Because it is a backend, I am creating a cluster IP type of service for it. And this is the metadata. This is a kind service. I had mentioned in your microservices architecture, we would be deploying applications in multiple replicas, and we would not be sending application packets directly to the app. Like this is my MHC backend, for example. I had given replicas is equal to 1. So it will create one replica. If you want, you can specify replica is equal to 2. It will create 2 instances of it. And when you create a service, you get a static IP address for this. But this service is cluster IP type. So it gets an IP address which is resolvable only within the cluster. And that's the reason it is called cluster IP. The front-end application, which would be existing, that will also have instances. I can have multiple instances of it. So I can say the front end, rather I'll say front. For that also, I'll create a service. But this service needs external connectivity. So I will create service of type load balancer. This would go ahead and create a cloud load balancer, a cloud standard load balancer. And whenever this load balancer receives the packet, this is a cluster, right? This is a cluster. So cluster will have node. The packet would come to the node, and from there it has to go to the service, and service will forward that to the actual application pod. So your users would be coming here. Suppose you are deploying 𝐀𝐠𝐚𝐧𝐝𝐚.com. Your users would be resolving that to cloud load balancer's public IP address. From here, the finished up, it will go on a specific port number on the node so that it gets forwarded to the service. And from the service, I have 2 endpoints for the service. Both the front end pods would be there, and we would be able to connect. Now, when my front end wants to talk to the back end, it would be sending packets like this. And here again, the redistribution, or rather I'll say the load balancing happens. And from the backend, it can fetch. If I find it in the cache, well and good. If I don't find the data in the cache, where will I go? I'll go out to my MySQL database, which is running on Azure. So Azure SQL, sorry, I said MySQL, Azure SQL database, which is there. This DB is running in one server. This connectivity I have done. So if I get it from the cache, well and good. If not, I go to the actual DB and I fetch the data and I provide the users. So this is what we are deploying. And now coming back to it, that's the reason this is cluster IP. Just a second, let me sip some water. This is the backend. The deployment has happened, and the deployment is created, and I'm creating one replica of my front-end application. I would go ahead and specify the image here. Every time I'm saying latest, whatever is tagged as latest, every build with the latest one. Otherwise, you can use a variable here with the build ID, and you can go ahead and pick up the latest images. This service is nothing but, you can see here, I'm picking up this image secret, my secret key, that would be picked up to talk to your Azure Container Registry. I'm setting some environment variable. Redis is nothing but the container name, or the pod name, I would say, the service name rather. This is the name of the service, the backend service. My packet has to go there. So wherever I address Redis, I would be sending the packet here. Frontend is having load balancer type of service, and it is selecting the pods. So the connectivity between them can be stitched up. Now coming to the pipeline section, let me trigger the pipeline. I'll go ahead and I'll say run pipeline, or else you do a code chain that should trigger a pipeline. That also is possible. It would take us through the different phases. You can look into the links. And someone was worried about the YAML way of coding it. You can go here. You can see that whatever you have created in a graphical way, any task you pick, you can have the corresponding YAML of it. When you're learning, you people can pick up like this. And if you need to add more tasks to it, you can go ahead and click the symbol and add more tasks to it. I need few other tasks, build related tasks, any utility tasks, like I want to execute on the bash, some test related tasks, packaging related tasks, deployment related tasks. A lot of task templates are there which can be used. And the pipeline is executing. Let's monitor that. It will take a while to build the image. Here it has replaced the token. At present, it is going ahead and building our .NET application. That would take a bit of, it would build that. It would produce an image after this, and it will push the image, lock the image, copy the files, publish that in the artifact, and go ahead and finish this pipeline. This will take a while. Let me show you the last build which had happened. I want to show you how it looks like. So when you publish, the artifact is visible here. One published and one consumed. Consumed is nothing but the code. Published is nothing but, remember we had told we would give output as deploy. And we had selected all YAML files. That's the reason compose file has also come. And the DAC pack. You had given star with that. So whether it is your MHC AKS YAML or it is Docker Compose YAML, both are being picked up. Docker Compose is actually not needed. So if you want to just skip that, you can provide the specific name of the file. This is the Azure pipeline output place where the build output is produced and your release pipeline can pick up. This is ongoing. It takes around 3 minutes to build. You see here, it had taken 3 minutes last time. This is done. Here it has executed and it has, you can see here, aborting the container. It has built the .NET application. Now it is building up the image. This task is also done. It has executed the Docker file and it has produced an image and it has tagged it this way. The build number is 787. So it has tagged it this way and it has tagged it with :latest. This is one image tag and this is one image. Image is tag latest. Sorry for this. Okay, where did it go? Yeah. Now this is pushing the image to our Azure Container Registry layer. Few layers are already existing because the image was pushed earlier. Now go back to your Azure Container Registry. You should see a newer version of the image being pushed over here. 787 should exist. So here it is present and latest is also pushed. Good. Yeah. It has copied the files and it has published the files and it has finished the post job as well. Now you can see this pipeline is executed completely. Everything is showing up green and you have a build published in this pipeline from where the release pipeline will pick up. Because we had enabled continuous integration and continuous deployment trigger has also happened automatically. It has picked up. We had told whenever there is a successful build happening, continuously go ahead and deploy it. It is doing that. You can go ahead and look at the logs of it by clicking on this. It will first go ahead and do the DB deployment task. And after that, it goes ahead and does the AKS deployment task in which it would deploy the application. So I'll let this continue. Meanwhile, I'll go ahead and connect to my AKS cluster from here. I need to fetch my AKS credentials. For that, I'll have to execute a command, which is, if I execute CTL command, it will not understand on whom I'm executing that command. So I need to connect to my AKS cluster using this. It has a configuration file which gets populated. I would give the name of the cluster. Let me fetch it from here so that I don't make a mistake. And after that, you give the name of the resource group. This resource group in this cluster, I want to connect to. Let's copy from here. It will fetch a configuration file so that it can communicate with my cluster. 𝐀𝐠𝐞𝐧𝐝𝐚 get nodes command. Let's see, I had scaled that 2-node cluster. Has it worked out? Yes, I have 2 nodes. 𝐀𝐠𝐞𝐧𝐝 get all -n cube system. Let me check the status health of my cube system resources. Meanwhile, core DNS, kube proxies, metrics server, all those things are up and running. My application would be deployed now. So I'll just wait for the pipeline to execute it. Let me go to the release. It's still ongoing. DB deployment takes a bit of time. In case we have any questions in time, we can pick up that. I have tried answering the questions on flow, whereas as in when I was seeing the last question which I'd answered was Tarun's question, and I think I've picked up all the questions. In case I've missed any of the questions, you want to repost your question, please go ahead and do that. So DB deployment is taking a while. I had deployed this in the morning. So let me see, that version of the container should be up and running. If I do kubectl get all, because I had deployed that in my default namespace, I can see that. And this is my front-end application, which is deployed. This is the load balancer service. This is my back-end application, which is deployed. And this is the cluster IP address for this. If I go with this IP address, I should be able to browse my application. Let me try and do that. My application is deployed. If there's any issue with your front-end and back connection, you would not get this page. So this is what we had planned to demo today. AKS deployment is still going on. I'll leave it for a while. It should go green. It is just grabbing an agent for it. It says that it's deprecated and it would be removed. It's giving a warning. 16.04 agents will not be given after September 2021. Okay. Meanwhile, this continues. Let me pick up the questions. How can we have Kubernetes cluster version upgraded via pipeline? Using Terraform script, you can do it, Tarun. And how can you sync the DB in cluster IP? How will sync the DB in cluster IP? What's that question? I couldn't understand. How will sync the DB in cluster IP? How will the connectivity happen, you mean to ask? Then connectivity would happen because I have enabled these ports on the database and I've told that you can accept connections from the packets which are coming from the AKS clusters. This is a backend Redis. This will not call as a database. We would be accessing front end, and front end application is actually accessing the database. If data is not there in the DB, then how you are handled on the code level, that will tell us how the application will behave. It should say that this data doesn't exist. It has nothing to do with, say, Kubernetes. You mean to say high availability of this? Yes, I can have master and slave replication for this and have high availability of my databases. I can do that as well. So the data would be read from the read replicas and the data would be written to the write replicas in case we want to set up that way. Could you help us? Could you please help list the task we need to select in the deployment pipeline? The task which we saw just now, the DB deployment and the AKS deployment, these tasks are the ones. I have just execute this. This is nothing but just going ahead and specifying where your DB is, and it is publishing the DACPAC file for it. This is for the AKS deployment, wherein it will go and deploy your YAML file, the delta of your YAML file. Rahul is asking what's the difference between Docker Hub and Jfrog. Jfrog is used as an artifact for packages like I want to have Python packages or .NET packages. I want to download that, keep it in a central location, and all team members download that. In that case, I use Jfrog, but Jfrog supports these days with container image repository as well. Docker is just used for container images. So for that, you will have to use task associated to this. Here you are executing task. It is just copying the files. Instead of that, you can choose a different task here. So I'm publishing a DACPAC file. Your task has to be different. If that task is existing in Azure DevOps, to be very frank, I've not used that task before. If it is executing in Azure DevOps, you will find that and you can add that. So you can look for tasks and you can add that. Your packaging task or task. You can see if your type of deployment is existing, then you can do it. Or else you can have a script and you can create your own script for it. Okay. Tarun is happy. Yes. Yes, Terraform is there. We will come up with another webinar in which we will tell you how to deploy a cluster and upgrade a cluster using Terraform. Newer version of the application is deployed. You can see here 4 minutes ago. These are running from 11 hours. This is running from 4 minutes. So newer version of it is there. Team has already posted the quiz link on the chat. So please go ahead and have that link handy. We are opening the quiz for, I will say 2 more hours, and we would grab the answers and we will announce the winners on our Tech Scalables page. And we would go ahead and announce the winners on our webinar page as well. We would do it in both the pages. Now, moving on to the quiz winner stuff. Quiz winners would be getting backed books. There are 3 different books this time which we are offering. Two of them are related to DevOps. One is Google Cloud. So Pact has associated with us, and we hand over the books to the quiz winners. We have few other upcoming webinars as well, like our Kubeflow webinar, which is coming on August 24th, same time. Then we have a webinar series for Kubernetes, in which we would be talking about how do networking works in Kubernetes. There are different types of container networking, so we would be picking up those and discussing about it. Then we have another webinar on September 7th, which would be again related to MLOps. We would be using AKS, we would be using machine learning, we would be using Azure DevOps, and we would be stitching them all together so that we can have a end-to-end flow, build and automatically deploy a ML pipeline. Now, the last webinar in this page, it's not the last webinar by Tech Scalable, rather I would say one of the webinars which we have planned out. We try doing 2 webinars or 3 webinars every month. So this is another webinar which talks about security using Kubernetes, securing our cluster with network policies and all. So that we would be discussing. Now, as you guys know, we are Microsoft training partners, silver training partners. We keep doing Microsoft batches, but we are coming up with Google batches as well. Google batches are planned from September 25th. We would be starting it. We do love Google batches in corporates, but we have not tested that in the retail. So we would be starting with our retail batches from September 25th. And as usual, how we do our regular AZ400 batch. A glimpse of that you have seen today, a 2-hour session. Like that, we would have a complete 5 weekend sessions. 5 weekends in the sense 4 hours on Saturday and 4 hours on Sunday. You would be with us, and we would be taking you through the entire course of AZ400, which is the DevOps Engineer Expert. And you would be prepped for getting certified for AZ400 and working as a Azure DevOps Engineer. So I fear this was all from our side today. And in case you're interested in any of our offerings, let it be consulting, let it be training, you can connect with us on this phone number or drop us an email. It's pretty simple, sales@techscalable.com. So we'll look forward to having messages from you, feedback from you people. Did you like this session? What improvement, what topics you people look for in future? If you want to drop a message for that as well, that would work. I don't think I've overshoot it here. Hey, Shivam, you're here?
Yes, Pamta, thanks for the lovely session. And I'm here.
Yeah, so we have put the quiz link. Anything which I've missed, Shivam?
So the quiz will be valid for next 2 hours. So, and just for others, we will be announcing the quiz winners in couple of days, and the winners will be on the event page and will also be on the company's page. So if you're looking for any future sessions, please join us on the Tech Scalable's company page. Just follow us over there on LinkedIn. So if we announce any future sessions, then you will be the first one to know.
Cool, then all the best for the quiz, guys. I think quiz is very similar to our AZ400 exam. I've tried to put some questions that in case you're preparing, you should ace in that quiz. And we expect to distribute the books. Shivam, if you can post our LinkedIn page on the chat, because I can't post the message on the chat, the LinkedIn page link where people can enroll or follow us.
Sure.
Thank you. So, guys, you can connect us on LinkedIn, connect with us on LinkedIn, and follow our page. We keep giving a lot of informative posts across various technologies like Kubernetes, Azure, machine learning, and all. Yeah, there you have the link. You can follow us on LinkedIn.
Okay, so guys, if you have questions for us, then put them in the chat window. Okay, then I think Mamta, we don't have any new
Yep.
questions. If there is any question which comes to mind, guys, you can always you can say put that question to Mamta on LinkedIn, and stay in touch. We'll see you in the next session.
Yeah. Thank you, guys. Thanks for attending. Hope you people had a good time today, 2 hours with us. Thanks a lot and keep tuned for our upcoming webinars. Thank you so much. Bye. Take care. Thank you, Shivam.
Thank you.
Thanks,
Thanks,
Kopal.
everyone. Thank you. Okay, so I'm ending the broadcast now. Thanks, everyone.
Thanks. Yep, sure. Thank you.
Thank you.